This is No Name Podcast, and today we're having Thomas Dullien, also known as Halvar Flake. Halvar Flake. My English is not Englishing today. Thomas, thank you so much for coming. It's an honor to have you. How are you doing?
I'm doing fine. Thank you for having me. It's an honor for me.
Awesome. Today also Alexei is missing, so we're interviewing Thomas with Vlad. And just to catch up on the time, we we had a little bit delayed during our setup. Let's jump right into it. So, Thomas, I think the typical question you always get is that your path to career is a little bit unconventional one. You had some extremely diverse transitions between vulnerability research, security. Well, no, between mathematics, then security, vulnerability research, reverse engineering, computational efficiency, etc., etc. So, could you share what influenced your career path and research path, and basically what drove you all this time?
Yeah. Well, what drove me is a bit of a hard question, but I started doing copy protection stuff as a teenager, and then stumbled into studying mathematics by accident. So I just decided I need a degree. So the computers were first. It didn't I didn't start with computers and then stumbled into didn't start with mathematics and then stumbled into computers. I stumbled into computers, then studied mathematics because I needed a degree, and there was a certain arrogance on behalf of my dad that said, you don't study computer science. Computer science is like a foreign language. You know a foreign language, you don't study it. So anyhow, yeah, I did a lot of computer security for a very long while, and then I kind of ran out of motivation to do it because the incentives in security, depending on what you're doing, are not always in happy alignment, so to speak. So what you would want in life really is something that talks to your technical interests, like what is it that you really like that interests you, and that also has an economic incentive where if you're good at it, you get paid for it, and then lastly, something that aligns with your values, so you can feel good about what you're doing. And with security work, I found that on the offensive side, the technical competence is very nicely aligned with earning money. Like if you're very good at finding vulnerabilities, you earn good money. But then the value component gets to be very, very complicated because you need to sell these vulnerabilities to somebody, and things get very, very messy and out of control there. And then on the defensive side, to some extent, the most effective defenders in industry are those that can have a lot of organizational impact in a large organization without necessarily having a mandate, which is a very different skill set than staring at disassemblies.
Yeah.
Right. And I think I realized that my life, like I'm not ideally suited for a career where I try to get stuff moving in an extremely large organization. And I also got tired of all the complications on the offensive side. And then I was looking for something where I can stare at disassemblies and look at low-level stuff and high-level stuff and so forth. So something that aligns with my technological interests, that still pays me, but that doesn't have all the headaches on the value alignment side. And that's how I got into efficiency work. I think the other part is that I've always admired people that had multiple careers. So there's a friend of mine that was profiled in a recent FRAC, Gera. Gera's first career was vulnerability research, and now then he became CTO of Satellogic, like a satellite company, and dealt with these things. And then now he's doing a little bit of security again. But in the end, I admire people that after having done something for 10, 15, 20 years decide, hey, it's time to do something else, and still have the courage and the energy to pursue something else. So I think I was also staring into the mirror and be like, you really want to be a one-trick pony all of your life? Time to try a second trick. So
Awesome.
that's how I got there.
It definitely take this mindset of being open to things and have a little bit of resiliency and bravery to be a novice again in something, to some
Yeah,
degree at least. Maybe not
yeah,
if you start completely different path, but still.
Yeah, I'm a big believer in writing. I like reading obituaries, funnily enough. I think they're great pieces of literature. And to some extent, one of the paradigms under which I try to live my life is I try to imagine what obituary I would like to read about myself. And then I try to live a life that will give me an approximation of the obituary I would like to have.
Nice. Given your background in math and low-level systems, right? What would you say, and your experience, of course, like doing these multiple transitions and working a lot on, in security field specifically, what would be the shortest path to produce new competent reverse engineers and exploit mitigation specialists? In maybe starting from university, etc. The folks that are going more conventional ways, right? Maybe there are some shortcuts for them.
Yeah, it's a good question. I'm not sure whether I'm very qualified to answer it in the sense that I've never spent 15 years trying to get people up to speed, right? I've trained people individually before, and some of them have turned out really well. But one thing that I've observed is that the few organizations that I've seen that have really excelled at recruiting or building out great talent in this realm, they take an approach that seems more like mining uh, than taking one person and converting them, so to speak. So you need a fairly broad funnel, and you take people in, and you invest in all of them by training all of them, and then there's only a certain fraction of which will really become passionate for the problem, like they'll really get the bug, and those will then go on with a lot of their personal lives invested in the problem and a lot of passion and do good stuff. But to some extent, you need to take a reasonably broad funnel and funnel a lot of people through a basic education in that sense, and then provide enough food so they can go on. Um, at least that's my observation. It's very hard to teach, like to just teach somebody that doesn't have an inherent deep interest in the subject to become a good reverse engineer or exploit person. Um, like the willingness, like so much of that work has to do with perseverance and
Hmm.
grit, like the ability to continue in the absence of positive feedback.
Mm,
I think there's a part of it where it's almost a psychological character trait. Like in the Big Five personality test, there's something called conscientiousness. And there
mhm,
was some psych research in the 2000s about grit, which is correlated with it. But so it would be really interesting to see whether people that score high on certain psychological metrics also perform well as reverse engineers. But I think aside from the raw intellectual capacity that you need, you can use it in many different fields. But reverse engineering and VxClass is very strange in the way that you get very little positive signal for very extended periods of time. And people need to, like, in order to become good at it, you need to be able to stomach these very long periods of no positive feedback. Um, and yeah, I don't quite, I mean, I think you can certainly nurture these qualities, but there's also some amount of people just have to have it in their personality trait that when a problem pushes back, they're willing to throw 6 months of their lives against the problem. And not everybody is that person, for better or worse, right? Because the downside that I've observed is that a lot of very good reverse engineers and vulnerable people, they're personality wise not prone to needing external validation, which also means that they're quite often not very receptive to external feedback, right? So it can be a bit of a catch 22. So anyhow, if I was to try to ramp up a lot of people, I would try to have a broad funnel and get people interested and motivated and teach the basics to everybody, and then see which ones of these really go into it with a lot of enthusiasm and want more. Because there is a certain number of people for whom this becomes an almost addictive thing, and it's those that you need.
Have you experienced a case where people would initially have enthusiasm, but then it fades out?
Yeah, I mean, that happens. I've talked to more than one person that said after 10, 15 years, I got rid of, or I got sick of staring at IDA. And burnout is a real thing in that field as well, right? Dave Vitale once said running a vulnerability development shop is almost like running. Well, I think he said the the issue you have is often more preventing people from burning themselves out than motivating them to go to work, right? Because it attracts a certain personality type
Mm-hmm.
that has difficulty finding a balance there. So I've seen more than one person burning out on this and then not doing it for a year or more, or sometimes forever.
Right.
Hmm.
Well, do you want to cover the part about Cycon? Because I've only seen the video of the talk. You've probably seen the whole thing and also the after party, so to speak.
No, I won't cover that. I will ask straight away. When next we can see you on Cycon with the keynote? Because you produce quite good ones. Just absolutely, like measuring in absolute terms and in comparison to the content that was presented this year for some strange reason. It was quite obvious, but that was quite a show. The keynote and the interview afterwards were quite exciting and insightful and inspiring. The same as the last time you gave a keynote at Cycon. Just it's not possible to compare the two because they were quite different. And just following up with your answers now, the thing that surprises me the most is the angle of this transition, because for me, these topics are somehow related on the fundamental level. So when we come to basic science, possibly there is like the ground basis that spans over these 2 or 3 fields of knowledge that you transition through, but they are different. They're quite different to me. I just cannot imagine how it would be possible. So practical question, how long did it take each time, if you remember, of course?
And to create the keynotes.
No, to transition between the knowledge areas in the career.
Yeah, it's a good question. I think my rule of thumb, like when I started copy protection work, I don't think I got any good at it until about 3 years in.
Mm-hmm.
And I think for most fields, if you look at a basic university degree, that's what 3 to 4 years.
Mm-hmm.
So I think if you manage to invest the equivalent of energy that a good student invests into a field for 3 years, you can skill up in a lot of different areas. Like I think if you were to say, I would like to become an acceptable cartoonist, I think the majority of people, if they put themselves in front of a drawing board for 3 years for a couple hours a day, they would become an acceptable cartoonist. Not a great cartoonist, but I think for most fields, my rule of thumb is it's an insane rule of thumb as well, right? It shows an arrogance and silly ambition that is not always realistic. But as a kid, as a young man, I decided, okay, if I want to learn something, I need to calculate about 3 years of really applying myself in order to get any good. And that's been, I think, broadly true for most things that I've tried to do. Now, that said, performance work was so similar to the security work. I think it only took about a year before I got to be reasonably productive, even less. Because a lot of the stuff that from low-level computer security just carries over, like data structures, caches. How does the system work at the lower levels?
You're just looking for a different type of flaw.
Yeah, it was really like the overlap was so similar. For example, also when I started in copy protection work, I pivoted into security later on. But so much of security, like what you needed for security work at the time or for writing exploits at the time, was very similar to what you needed for copy protection work. Right, so there's overlaps. And now when it comes to the Cycon keynotes, I mean the 2018 keynote was really summarizing something I had been thinking about for multiple years beforehand. All the weird machine stuff and me writing that paper and trying to get a grip on the formalism, etc., etc. So there was a lot of other work, adjacent work that went, like, which then got distilled into this nicely digestible talk. And then this year's SciCon talk was a weird one because I hadn't asked to give the presentation at all, more or less. I had said I don't have anything useful to present beforehand. And then later on, I was told, hey, can't you do a 15-minute impulse talk beforehand? So I needed to come up with something. And my rule of thumb has always been, if you can sit in a bar and talk to a friend about something that interests you, and the friend stays interested for about 45 minutes to 1 hour, then you have a keynote. Right? So whatever you can fill that amount of time with something interesting.
Your 45 minutes, it's quite a lot.
Oh yeah, it's a lot. Now, but in the case of this year's SciCon presentation, I mean, my brother's an economist. Economics was always something that was discussed in our family at all sorts of bizarre levels. I could go back to my childhood. My father, when he tried to entertain his kids while going for walks, he liked going for long walks on the weekends, and you need to entertain his kids. And one of the things he did was telling us the history of bank robbery, because bank robbery is cool. I just like to listen to that. Now, but if you listen to him carefully, he would start out with, where does money come from? Exchange of goods, and you need to somehow transact and so forth. And then only very much later on, you come to banks and paper money and safes and so forth. And it's kind of amusing that his older son became an economist specialized in where does money come from, and his younger son ended up doing computer security, right? It's almost a natural outgrowth of these stories. So be careful about the stories you tell your kids. Anyhow, the SciCon talk was just me condensing a bunch of frustration I had about European industrial policies into 15 slides. So I think the frustration had been long brewing.
Let's maybe stay on that for a while. So it intersects with the things that interest me the most nowadays, right? I've asked you different weird questions after the talk, trying to find connection points, these intersections, and maybe asking for your advice, because with the experience like that, most probably given these surprising questions, you would come up with quite good ideas and where to proceed in trying to solve them. So we discussed, for instance, this gamification model that the Ukrainian military has implemented regarding the in its search to find an adequate way to correctly distribute UAVs, right? We've created, not we, the military have created the rating system that basically creates incentives for documentation, visualization, and colorful reporting of fire strikes, which even from theoretic perspective creates a lot of problems and effectively creates the market of information products that without regulation and proper intervention, timely intervention, can degrade quite quickly. That's fortunately not what we observe in reality. Yeah, so this experiment has a very efficient feedback loop. So probably it will not end up being this degraded market, but it well could. But at the moment of us talking about it after your talk, it was quite a possibility. So it was risky from the beginning. I don't think that people that implemented it were actually conscious of that risk. They tried and somehow they managed to make it. But there are many other areas where economy actually translates into the battlefield, not only in terms of stages of logistics and communication, but in the battlefield itself. For instance, what comes naturally from your ideas is that the West is not prepared for the type of warfare that Ukraine wages nowadays against Russia, right? Just trying to swarm a more capable adversary with a lot of very cheap, very simple, and not very easily but integrated solutions, right? It's questionable if Europe would ever fight such a war, because Europe has abundance of more pricey armaments, right? But if it came to that, most probably it couldn't, just because all the supply chains are somewhere in the Asia, and Asia is not really an ally in such a situation. So just working from here, did you have any like afterthoughts? Did you come up with any like possible solutions to this situation without rebuilding Europe's economy from scratch? Is it relevant? Is it still relevant after half a year? Is it? And if it is, are there any possible effective solutions?
I mean, to some extent, it's relevant in a variety of different. It's relevant in a variety of different perspectives, because like one area where outside of warfare this is becoming relevant is just industrialization and staying industrialized. Because one of the things that I'm talking about is that if you give up volume production, you also give up a certain amount of ability to innovate. And if you look at the crisis of the German car industry and the German car supplier industry, as the internal combustion engine loses in relative importance with regards to EVs, there's entire areas of the country that are going to go either away or will need to find something else to do. So this loss of the ability of volume production is not only a security problem, it's also a long-term economic problem, right? Because if you stop doing something, you lose the ability to do it. And I guess my view is that, for better or worse, Europe needs to solve two problems at once. They need to solve, like, if they manage to solve the how can we still produce things at volume, they solve both the security and the economic problem. But if they don't do so, then they solve neither, which is going to mean economic decline and less ability on the defensive side. Am I making sense?
Yeah, perfect sense. So there is a limit to economic globalization for as long as there are nations, right, with different geopolitical priorities. But at some point, you will have to pull back and stay industrialized, not outsource all the goods you produce somewhere, and stay, I don't know, and learn how to draw, right?
And I mean, it's also interesting if you look at, like, there's really good books on, or just good research on late industrialization, meaning like if a wave of industrialization happens and you miss the boat, then it's very hard to catch up. And there's only very few examples, interestingly, most of them in Asia, of late industrializers. Japan being the most important example, and then South Korea being an important example, and to some extent China being, or not to some extent, clearly China being an example. And it's going to be really interesting to watch India now that people try to diversify their supply chains away from China into India, what effect they'll have on industrial know-how in India. But long story short, all of the late industrializers went through a phase of mass production. It was a combination of mass production, but also government intervention to some extent to help obtain and retain mass production. Yeah, and to some extent, that's like some of it is against textbook economics. Like, textbook economics would say that money will flow where it can have a lot of effect, and then investments will happen and production will move there, etc., etc. But then in reality, all examples for late industrialization we have had some amount of government intervention in the markets. On the flip side, there's many examples of it having failed as well. Like there's examples where Brazil had a fair amount of investment in domestic car industry, I think. Like India trying to shield its domestic car industry, etc. Like there's a few examples where entire countries managed to do late industrialization. There's also a plethora of examples where government intervention in order to shield or create a domestic industry failed. Yeah, long story short, it's very unclear what's the right way to do it, but you can watch something like, or somebody like China and see, well, clearly they managed to go through mass production and then through mass production to higher quality goods. Japan, South Korea, etc.
Anything you want to add here, Vlad, or we can move on?
Yeah, that made me think. But the thoughts are very sad, so I won't share them. I'm just trying to to put it on the perspectives of Ukraine after the war, if that after ever happens. So it's
I mean,
sounds like a missed opportunity. That's not the way we need to move to. But
if I may strike an optimistic note, I think clearly for domestic, like a Europe-based drone industry, a lot of the expertise is now in Ukraine.
Unfortunately.
So unfortunately, but if the war was over, that expertise would still be there, right? So
it's a very optimistic statement, I would say.
Okay, fair.
But still in Europe.
I'll concede that.
Probably, yeah. Yeah. Not to correct you. That's quite fair. That's and yeah, it gives hope. But excelling at this kind of disciplines only bears fruit if if there is more wars.
Yes, but the industry itself does not necessarily need active wars in order to exist. In the sense that there's an argument to be made that drones have a lot of quite useful applications outside of war. It's just that at the moment they're not quite there yet. I mean, I originally at one point before doing Optimize, I considered doing strawberry farming robots. Don't laugh, but small machines that go through a strawberry field hunting pests. And I decided
what stopped you? It sounds like a fantastically great idea.
So it's very, very hard to compete with human labor. And and as anybody who has any experience with ground-based vehicles knows, nature is a fairly unforgiving thing when it comes to technology, like keeping things out of the mud, away from rain, running in spite of the conditions and so forth. So if you look at agricultural robots right now, I mean, I live in southwestern France. The main area where they are applied is in very high margin areas like super organic wine production, because there you can afford spending these devices. But in most other areas, just pesticides and human labor is so much cheaper that robots have a very hard time competing. But long story short, I think drones are going to be, or unmanned vehicles of any sort, small scale, medium scale, are certainly going to be an important industry, irrespective of wars. For warfare, of course, they're going to be important as well. But the expertise in putting these things together and all the engineering that goes into it and making stuff is valuable.
I think also economics is just part of the successful strategy, because US, for example, always had good spending on military stuff, so to speak, but at the same time, because they did not have this open kind of conflict, right, the one that Ukraine has now, for example, with Russia, their direction kind of shifted towards what you actually, the same thing as you described in the talk, right? They produce expensive, advanced technology in low quantities. They have $15 million drones, but only few of them. Russia sends 500 Shaheds every night to Ukraine, right? So even if you have the economic kind of power, still you may not end up developing in the right direction.
I mean, the other part is that if you look at the entire, let's say, post-1998 trajectory of military interventions, and particularly the global war on terror, as it was called at the time, a lot of militaries, particularly Western militaries, got this strange idea that future conflicts are always going to be a small number of extremely expensively equipped soldiers against a large number of soldiers with almost no resources. I mean, if you look at the Afghanistan war and the Iraq II war, the resources on the side of the Taliban, or the technical resources on the side of Iraq, were just there was no comparison, and there was no domestic production capacity of any sort. Like, the idea of having a conflict with even a near peer just disappeared from a lot of military planning. And when it disappears from planning, it disappears from procurement, and then the industry to support it disappears. Yeah, if you read the literature at the time, people just assume that all wars of the future are going to be small wars of this type.
Yeah.
And I think it's fair to say that Russia's invasion of Ukraine surprised a lot of military brass, in a sense that, like, I actually had a fairly senior military person tell me, I never thought I would see a war like this in Europe ever again. Like, nothing in our planning ever looked at this, or looked like this. Like, there was an element of strategic surprise where everybody just had assumed that this is a thing of the past.
Yeah, absolutely.
Which is crazy.
That's why in our preparation doc, right, when there was one answer you had about how about infrastructure in Ukraine, etc. And there was just one sentence that caught my eye. Russia will not bomb AWS US East 1.
Yeah.
And I'm like, this is the same level of confidence. This is the same level of confidence. Yeah, we had like prior 2022 about Russia going full scale invasion.
Yeah. I mean, the reason they would not bomb AWS East 1 is because like, that is one of the few things that would actually force a response on behalf of the Trump administration. Like, there's no way.
So let me correct you then. They will not openly bomb the East Coast in an easily attributable manner.
So Russia will not do anything that will make the US get really involved.
For now.
No, I think, like, in general, it's just bad strategy. Like, the one thing that Russia wants to avoid is the US getting drawn into that war, like, seriously drawn into that war. It's like the number one thing they want to avoid.
Really, it resembles the current memology in Ukraine, right? So we are constantly surprised by the lengths that the US and Western alliance, NATO in particular, are willing to go in order to, like, reinforce this statement that Russia doesn't want an open conflict with NATO or the US.
I don't know whether I think Russia would want an open conflict with NATO ex-US.
It's just again, it's
I would say that, like, they shouldn't
it's
want
precise calculation. When you're dealing with Russia, this precision always fails you, because Russia first is known for making, like, quite illogical strategic decisions, right? And second, like, the West is constantly lacking intelligence and understanding of Russian strategic culture. So I completely disagree that they wouldn't want that or would try to avoid that. They're completely happy with the West not wanting it and trying to avoid it.
Right.
for
Right.
as long as possible. But them, I have no idea. That's not that I'm like moving this aside, right? It's a logical idea, and I am not trying to directly convince you that you are not correct or they are not correct. I'm just saying that with them, you never know.
Yeah,
You really never know.
I think the broader point, like why did I even write Russia's not going to bomb US East 1? Now the reason I wrote this was I think it was around what extent is the use of external vendors and services, even for things that are critical to your sovereignty, a good move. And the amount of risk that Russia would incur bombing a data center in Ukraine versus bombing a data center in the east coast of the US
the risk is
just a
different for
very,
sure.
very different strategic categorical risk on behalf of Russia, right? So,
And then, and
Yeah.
another
I
point is
think,
that sorry, and another point is that considering Vlad's talk on PsyCon, if Russia would bomb US US East 1, they would probably hit part of their infrastructure as well.
Yep.
that is also
ironically.
that is also very true, right? Yeah,
But
I
again,
think,
I'm just trying to reinforce that when Russia meets these risk calculations and they are not in their favor, they're not stopping thinking about that. They're thinking about more creative hybrid solutions in form of diversion or any other kind of active measures. So that's not that stops them. That just reshapes their tactical tooling that they will try to apply in order to reach those goals. That's how they think. That's how they operate.
Yeah, makes sense.
And I think with Russia, it's just a typical. I don't want to call it mistake, but I think misreading them is trying to use traditional game theory, right, and rational thinking, but their values, I think, are so skewed and different from the Western that they dictate, like, their rational decision is very different from what a common Westerner would consider as a rational decision, and that's why it's.
Yeah, I mean,
I think we are like we shouldn't go there because we will just now strategically mock Russians' way of thinking, but
not necessarily. My point is that. Sorry, go ahead.
I'll jump in really quickly. I think rational decision making in conflict or in certain situations is very, very paradoxical in some sense, right? The classical example is this classical game. Somebody, like, there's two players. Somebody gives player A $100. Player A gets to distribute the $100 in whichever way they want to between the two players. Player B gets to say yes or no, I accept or I don't accept. If player B accepts, both get to keep their share. If player B says no, nobody gets anything. Now, the rational thing for player A to do is to do $99 to him, $1 to the other, and then the rational thing for player B would be to say yes, because he's still better off than nothing. But this is really interesting because it shows you that because it's rational, but it violates our notion of fairness.
It's not intuitive, yeah.
It's not intuitive, and also you can argue that it's wrong for B to say yes, even though it would be rational to do so. Right, so to some extent, in conflict and negotiation, the rational option is not always the right option, and I think that's
that's a very good point.
Rational is not always good.
Yeah,
it's not even reasonable most of the time.
I mean, to some extent, if A needs to contend knowing that player B will flip the table and be willing to incur pain and act irrationally, then player A
that reminds me of Russian strategy, actually. Yeah, that's absolutely true. It reminds me the talk of a Finnish intelligence colonel. It's still available on YouTube. A great guy. I cannot remember his name, but he's brilliant, and he put all his life into researching the Russian strategic culture, and it's quite quite well said. Everything that he like produces, it should be learned by all Western strategists, and somehow they just completely dismiss Finnish experience. In fact, that's what they have to learn from exclusively, because that's possibly the before Ukraine the most like fresh and actual observation what about Russia and how it actually thinks about security, safety, its internal resources. It's two simple things. First, like strategic paranoia as like all encompassing way of thinking, not even thinking, like reacting to what's happening abroad, right? It's always against us. We are always the target. They think how to like grab our land. They think how to subjugate us, all that stuff, right? And second,
somebody's trying to steal Siberia.
Yes, exactly.
Yes.
And second, like enormous, like unmeasurable capacity for suffering.
Yeah,
because it's the most important strategic reserve that they have. They can outlive you, outstruggle you just on that, right? And that's what always like skipping the attention of Western strategists for some reason. No, they won't do that. It's not rational. It's not rational if it's you. It looks completely rational to them. We will do it in 3 days, or we will still outlive you. So what do you do about that?
So just switch our focus. Sorry,
somebody
go
has to put the link to that talk though in the show notes, because I want to watch it now.
Oh, I will.
Okay.
Of course. I actually asked like feedback, like a comment about that from Mikko, and he said that like literally he said that that guy is as real as you could get. It's like a very well established and known for this kind of expertise guy in Finland. Of course I will share.
Suggesting to switch the focus from trying to understand Russia to what Ukraine can do in response. So, Thomas, if you had authority for 1 year over cyber in Ukrainian government networks, infrastructure, etc., I don't know, you would be the Ministry of Digital Transformation of Ukraine for a year or 3 years. Which 3 engineering practices would you enforce? Like, what are the primary areas you would focus on?
Well, first I would ask, what did I do to deserve this? But then, secondly,
just bad luck, man.
That sounds like the actual guy doing his work.
It's karma. It's nothing related to what you did. It's something from past lives. It's
okay. I think the other thing I need to be careful about is armchair quarterbacking in these situations is very, very difficult, right? I have no idea what the government networks look like, the critical infrastructure looks like, what has been done, what hasn't been done, what the material resources are, or even precisely what the Russian or other attackers' operational habits are, and so forth. So everything I say has to be taken from the perspective of I don't know what the hell I'm talking about. The things that I have seen successful in fending off government attackers are the following, or these are the ones that I would like to see implemented. The first one is a fairly boring thing to say, but bearer tokens of any form, like passwords, anything that allows persistent access to things in a not re-authenticated and non-trackable manner is something that needs to go. The issue with these things is that they allow a form of invisible persistence, like, because the possession of a bearer token is a form of persistent, except that it leaves no trace on the system on which you're persisting on, because you're not there. You can just access it when you need to. And that kind of destroys all the work of the defense. So the first and most important thing is minimize or get rid of any form of bearer tokens to the extent that you can. The second thing is try to strive for statelessness, like try to move everything that you're like all your mutable data, all the things that are variations of the norm, so to speak, move that into one area and try to have as much of your compute infrastructure be as stateless as possible. Because it allows you, like, as soon as you're stateless, you can re-image machines, you can replace machines, and so forth. So if there's suspicion on a machine, you can just swap it out and be done with it. Just a fast way of dealing with things. So statelessness is nice because it also engenders a form of resilience. A stateless system is one that you can very easily bring up again. And then the last one is standardize as much as you can of your software infrastructure so you can identify deviation. An ideal scenario, if you have a memory dump of a machine, you should be able, for every executable code page, to identify where is it from, why is it there, and for scripts running in user space, interpreters also identify what's happening there. Like, you want to be able to look at a machine and say, this looks normal, this doesn't look normal. If you look at the early Chromebook architectures, Chromebooks went a fairly, like the early architectures tried very hard to be as stateless as possible. And a lot of that architecture was informed by how can we have a useful laptop here when we have a state adversary, because Google did face a state adversary at the time. So so I think these would be my engineering principles. But then, I mean, if you manage to build an infrastructure that doesn't have any bearer tokens and that allows you to randomly re-image machines and swap machines all the time without any disruption to your operations, and where you can inspect suspicious machines easily, you've made a lot of progress to making an environment that is hostile, at least for an attacker to have extended persistence. That doesn't mean the attacker can't come in and smash things still, but at least the long-term persistence is something that you can make very, very difficult. Right, but then there's a million devils in the details for any of these steps. Legacy systems, how can you upgrade them, etc., etc. So
Yeah, I think that's also very quite often missed point that you mentioned in the first recommendation, right? Because often people do focus on the passwords, the obvious one, but the bearer tokens, especially the ones that are like persistent, right? So it's not like people complain about OSFlow why they're so complicated. Well, precisely because having refresh tokens that you have to actively exchange for a valid token that you actually use to do things, right? It's visible, it's not passive, versus keeping a token for a long time and then using it at the right time to access the resource. Absolutely. So with we're living in 2025, which is about our third year into the AI era or boom or whatever you want to call it. So what's your take on impact of AI technologies on this landscape? What does it change? Is it a game changer? Is it like a fundamental shift or just a qualitative change?
yeah, was the arrival of the internet a qualitative change? Right, the qualitative or quantitative, it's hard to tell. So what
Also, like if you ask someone in 2001, you would get probably a very different answer than now.
yeah, but also I think, yes. I mean, the arrival of the internet in 2001 did not feel like it was going to reshape societies to the extent that it did. So locally, I think a lot of revolutionary things do not feel as revolutionary as they are. Right, with any exponential growth, people underestimate how quickly it goes after a few iterations. Like, locally, it doesn't look so fast. I mean, the AI boom is real in the sense that a lot of stuff that used to be borderline impossible is now easy. Like, there's many things that 5 years ago you would have asked me how to do it. I would have said, I have no idea how we'll ever be able to do it, or not ever. But, and now these things are easy. One of my prime examples is when teaching people how to do code auditing 10, 15 years ago. One of the things I kept telling people is you look at a piece of code and you need to look at a guess of what was the programmer's intent. Like, what did the programmer want to do? And then you check whether what they wanted to do is what they did. And I had no way of automatically determining what was the programmer's intent in this piece of code here. and I had no idea how could I even write a program that takes a piece of code in and gives me programmer intent. Had I known that all I need to do, in quotation mark, is take everything written by humanity ever and run it through like a training algorithm, that's the right way to do it, I wouldn't have thought of that either, right? So, but I can give a piece of code to a modern big LLM and ask it, what did the programmer try to achieve here? And more often than not, it'll be correct. So,
Magic.
so there are things that there's lots of things that I can do now that were impossible. So this is a real revolution to some extent, like in the same way that the arrival of the internet was a real revolution. And it'll have very, very long-running consequences in many areas of society, as the technology trickles into society. I mean, 2001, the impact of 2001 internet on society versus 2008, even like 7-8 years later, versus 2025, there's just a big leaps. So, the other thing that's interesting is we've gotten this master algorithm, so to speak. Like many different problems are also solved using the same computational substrate, using the same operations. Like if you look at regular software, different things require different software. And now with LLMs, you've got many different problems, but it's all matrix multiplication. And it's for somebody looking at efficiency, it's actually very annoying, right? Because all your compute is always in the matmul. But also, this drives a change in the compute architecture, right? So now you get these specialized, like GPU style throughput compute machines that are really good at matrix multiplication. So yeah, long story short, while I have been an ML and AI skeptic for most of my career, I will not claim that LLMs, like the big LLMs, are not revolutionary in what they can do. And even if they stop progress today and there was no further improvement in what they can do, the impact of this technology trickling into society at all levels would still be enormous. So there is, like, society is going to be reshaped to some extent over the next two decades to look very differently. Yeah, I mean, I use them fairly regularly, and Eric Schmidt famously had there's the toothbrush test. Any product that you're using twice a day is important. And LLMs certainly pass the toothbrush test.
Yeah, I think it's you mentioned your AI. You've been an AI skeptic, and I'm too, in the sense that I'm not skeptic about the technology. I'm skeptic about the current kind of use cases and predictions. And I think historically we've just been, whenever a new revolutionary technology comes up, and it will be evident that it's truly revolutionary only after a while, in the moment we're terrible in actually predicting how we're going to use this revolutionary technology, right?
No,
And
come on, man. It's easy to be skeptical regarding predictions.
No, but I mean,
it's a very safe sport.
No, I mean they are. I'm not talking about like being skeptical about predictions, more like betting on predictions and then they don't work out, which is like, think of 2000 and then 2001, right? Internet did end up to be revolutionary. It's just not in a way that we thought it will be revolutionary in 2000. And I think same with AI. Sorry?
In 2000, we still thought there's going to be more than one retailer online.
Yeah.
So, let's not go there. You said that now it's at least revolutionary because stuff that was border impossible is now quite easy, right? For me, it's the other way around. Stuff that used to be quite boring, and I just constantly and continuously procrastinated against even starting doing it, because I knew it would take me like a few days, and those days would be probably the worst of my life. Now I just jump in, spend 15 minutes, and it's done.
Yeah. I mean, a lot of data processing problems, extracting structured data from unstructured data, has gotten really easy, like computationally expensive, but really easy to do. And it's the revolution in being able to generate structured data from unstructured data, I think, hasn't fully, like, people haven't fully appreciated how revolutionary that is.
Oh, many people did. They just they're quite a narrow craft, I would say. But people in intelligence, in military, they appreciate it very much, I can say.
Yeah.
So also related to this question, we were considering about will we see kind of autonomous fights between AI agents? And you had some thoughts on that as well.
Yeah. So I think, well, I'll speculate about cyber as a domain now. Whoa.
Oh yeah.
I think cyber isn't air, so we won't necessarily see dogfights of one cyber agent against another cyber agent, right?
Probably in the movies.
Yeah, I mean
now I think not even in the movies. But who knows? Sorry.
Sorry. I mean, who knows? I mean, I think it's important to realize that cyber is the default autonomous field already to some extent, because Stuxnet was autonomous. Like the last bit of Stuxnet, it wasn't an artificial intelligence, but it was certainly an autonomous weapon system. So I have no doubt that we will see more autonomous weapon systems in cyber as well, so to speak. But I think the way this conflict is mostly going to look like is that defenders apply AI to fix things and to improve their infrastructure. Like the job of the defender isn't normally to go directly after the attacker. The job of the defender, for the most part, is to fix shit, or to make sure things are defensible in the first place. So I don't think we'll see the AI to AI dogfight as much as we will see defenders leveraging AI tools to secure things, and attackers leveraging AI tools to find flaws, or to generate data that allows them better phishing campaigns or whatever. And that will be a sort of AI versus AI combat, but I don't necessarily see it as two agents dueling directly. I mean, yeah, I would really have to try to do sci-fi constructions before I see two agents.
Oh, it's a very inspiring thought. So, did you think about that same situation? Let's say it operational concept, right? But in slightly different context. So you are completely correct. I think that defense does not deal with offense directly most of the time, right? Unless it's like, real dogfight, like fighting for persistent success, for instance, during the time of incident response, which again only coincides in time and like cyberspace, right? But in fact, people are doing different things normally without knowledge what is done by whom, right? And this is the prerequisite for success. Offense is successful when defenders do not know these new tactics, right? If there are like unique TTPs that no one is aware of, or there is a 0 day, right? Defense is quite futile, right? And the other way around, if attackers are still using these operational concepts and tooling, right, and they are not aware that defense has like uncovered this operation and will just end it one weekend by removing all points of persistence, as two of our guests developed a theory about that, right? Persistence engagement is basically about these series of fait accomplis and the other side not having an idea that you are like operating in the environment. But if you slightly rotate this problem and target not the actual operational stuff, but underlying infrastructure, this looks much more promising to me, because that's actually already happening in the wild. A lot of threat intelligence companies are basically just uncovering infrastructure elements, identifying that, yeah, these are C2s, these are proxies, these are staging platforms, all that, and sometimes mistakenly attributing them to groups or countries, but most of the time just pulling them out of the internet, right? So if you create an agentic AI that is specifically focused on finding out what different groups are doing in order to maintain their operations on the infrastructure level, and then just searching wildly for all those features in the internet, which is not too large for that to be practical, right? That would be quite a dogfight, I guess.
Yeah.
Because if you take this feature of cyberspace, of operations in cyberspace, as features, as series of fait accomplis, that's quite it.
Yeah.
You know?
I mean, would be interesting to. You would essentially need an like I was thinking of a scenario where you have an attacking persistence agent and a defending forensics agent.
Yep.
That would be some sort of dogfight. Yeah.
Sounds like a business idea to me.
Yeah. The thing with all business ideas in security is, unless you know how to sell it, it's not an idea yet.
It's not a business idea.
Right. There's many good ideas in security, but very few are business ideas, unfortunately.
Yeah. But it comes with implications, of course. It's not very safe to just let them out there doing that stuff.
So personally, I'm very, very relaxed about these things. Like AI safety in general. I think the worry about AI safety has greatly
very
exceeded
interesting. Really?
Yeah. But I mean, I'm on the record as somebody who did never worry about the doomer narrative. But I think there's many other practical problems that are much harder than dealing with the safety questions.
For instance?
I mean, the reality is that AI systems get sidetracked really easily, and they lose context. Even when you have massive context length, they're still, as the context grows bigger, they tend to lose track of what they should be doing. And it's just, I subscribe to all the expensive models to run experiments, and the number of times that the AI just has terribly crap ideas and goes off on a tangent, like it's we're nowhere close to where we need to be to have an AI. I mean, there's this curve. How long can an AI work on a problem before it goes off the rails on average? And I think we're reaching a point now where it's like an hour or so, and that's great progress, right? But for me, at least in my personal experience, all these AI systems only work if I'm extremely precise in describing what outcome I want. And as soon as there's a lot of leeway in what to do, they can be relied upon to make very poor choices.
I would add, and the model has a way to kind of somehow measure how close they get.
So I mean that as well. You need verifiable rewards, but
yeah.
By and large, I mean the technology is super impressive. I use it all the time for writing code that I wouldn't want to write by hand. I use it for many things. But I'm also routinely surprised at how awesome it is, and then I'm also routinely surprised at how terrible it is. And there's this jagged edge in capabilities where it just drops off a cliff, and you can never quite tell where that edge is.
But
so yeah,
it's the same with humans.
I guess.
There are people that if you give them a task that spans over a few days, they just die in it. Yeah. You know, they just try to storm it and they fail and they fall, and yeah, that's that's it. But if you give them something like simple and fast, they can take it in enormous quantities and excel at that, right? So it's maybe it's an inherent, like, a fundamental fundamental feature of intelligence, and it just scales regarding how advanced or otherwise specific that intelligence is. But it's quite interesting that you are skeptical about that on that basis. Don't you think that with time they will evolve to the level of capacity where they want no longer will be a problem?
So, I mean, I think they'll remain in the technological realm in the sense that they will improve, and humans that use them will improve. I don't think a rogue with the AI, that's the problem, and not the AI itself, if that makes any sense. By the way, another thing I've observed is that when it comes to having AIs do non-trivial problem solving, there's a real tendency to having multiple context windows. So the one AI does the planning, and then it hands off an individual task to another round of it. And that's largely to keep some sort of hygiene in the context, right? Because if you make the plan and then you go off and try to solve the first problem in this context, it starts polluting all the reasoning thereafter. And that's a function of the way these things work, right? Because the entire context is always taken into account. And I think it's interesting because I'm not quite at the bottom of where the capability. Well, nobody is, but I think the capabilities as you go the model where one model or one AI generates prompts and context for another AI that then does
That's exactly what I thought about.
That's a much more promising avenue in many ways, right? Because but also from a security standpoint, if you think about tool use is pasting stuff into your context window, right? And so it's almost by design in agentic systems, there's no proper separation between instruction and data. Which
so
creates
all that we tried to solve for all this time, we're still at square one, or what?
Well, worse.
Still separating data from code.
Well, I mean, it is possible to build architectures and neural network and LLM architectures that do some amount of separating data from code, but I'm not sure whether we even know what that means, right? Because the data needs to influence what the AI is doing next. So almost by design, it's difficult to understand what separating instruction from data would look like. I don't know.
Then if it's LLM, right, we gotta remember that it's still a very advanced token prediction machine, and it actually tells more about how we, like philosophically, if you think about it, right, it tells more about the way we communicate rather than the way we think, because it's all based on text.
Yeah, but in any case, that's a very interesting and exciting field to research. I would say. Yeah.
Speaking of like ideas and beliefs, so across your roles in startups, right, and enterprises, what belief about security or tech and defense you held some time ago that you now believe was clearly wrong, right? What changed?
So as a young man, I clearly, as somebody who came from a reverse engineering and VxClass perspective, I overestimated the importance of exploitation. I mean, it's important and useful, but I should have invested more time into properly understanding Kerberos and a lot of the authentication infrastructure much better. Because if you look at all the Active Directory shenanigans everybody's playing and so forth, having a very solid understanding of the authentication and authorization infrastructure is much more useful to an attacker than I understood as a young man. So
Vlad is smiling because that's what we talked last time.
That's the text that I'm writing right now. That exploitation against like general understanding and using legitimate access just fails when it comes to operationalizing in cyber domain. It's just a tiny bit of exclusive luxury that you can live without, and there is a very small amount of problems you can exclusively solve with it only, right? and everything that remains is much more important, and the complex identification and the authentication protocols are at the cornerstone of that problem.
Yeah, definitely.
That's the first principle that you advised. It's basically exploitation, let's call it, but not of the software flaws, but the complexity and the complexity. First of all, complexity of those things that just exist, because I don't know. Yeah, I have no idea how Kerberos came to life. Really, it's such a monstrosity.
It is a monstrosity. It's also what most of the world's authentication runs on, right? So it's a good idea to get involved deeply. I overestimated the importance of virtual private networks in the future. Like, I invested a lot of my youth into reading the ISA-KMP specs and IKE specs. And I had a paper, like you could buy a paper version of the IPsec protocol suite, RFCs, printed as a book. And I used to take that on flights with me and read and mark it up. And it's a technology that's no longer nearly as relevant as I anticipated it would be. So that was a poor investment of my time.
It's better to ask AI what they intended to implement with this code. Okay.
Yeah, I think we often get carried away with something like advanced and complex, like exploit. Right? Sounds exciting, similar to how
challenging task to accomplish. Maybe, right?
Yeah, not a routine.
As a young man in high school or coming straight out of high school, you haven't seen a big IT infrastructure, right? So writing an exploit is something you can do. Getting a piece of software that you want to attack is something you can do. Understanding the intricacies of enterprise deployment of Active Directory, that's something that is much harder to get started in.
And doesn't sound as cool.
Doesn't sound as cool either, right?
It was hard. Nowadays, Hack the Box, I guess, have like quest lines like these RPG trees, and one of the branches is dedicated exclusively to Active Directory because it doesn't seem to go anywhere anytime soon. Yeah.
I recently gave a talk about like adoption of post-quantum crypto, and everyone got excited. Wow, post-quantum crypto! But like, and as a cryptographer, I'm also excited about it. But as a security professional, I understand that majority of the system aren't gonna be broken because they don't have a post-quantum resilient key exchange. But because they still have a SQL injection or some kind of bearer tokens that leak. Yes.
My first Black Hat US I ever attended, 2001. I had started studying mathematics, cryptography. I had some person, much more senior person from the US, like employed by the US government at the time, tell me, you really need to focus on quantum stuff because that's going to be the most relevant for your career. I have never
2001.
I've never been so glad to have ignored advice.
Yes, I'll tell you why. Because that's when nice. Grover's and Shor's algorithm came to be, and the first quantum computer showed up in 1998. So everyone thought this was going to be a big deal. But then fast forward almost 30 years later, we didn't make as much progress as we expected.
My current conservative estimate is that quantum computing may be very important for my son's career, who's 6 at the time. Yeah. So we shall see how it goes.
That sounds about right. IBM plans to have a kind of cryptographically relevant quantum computer in the next, like, roughly 15 years.
I don't know, guys. We were joking about AI not keeping its promise for decades, and now look at us.
AI is keeping its promises much more than I had anticipated. When, like, When Stable Diffusion came out, I had no.
No, I mean, like in the 90s, a friend of mine in the university was planning to research neural networks, and I said, why? We will not have this computational capacity ever. Look at us.
Yeah.
20 years later.
Yeah, I think, I guess one thing that AI's progress has really done to me is I don't think I've ever had less confidence predicting what compute will look like in 5 years.
Mhm.
Like the arrival of Stable Diffusion and the arrival of LLMs were both outliers in what I thought was possible. Like if you had asked me to predict what's happening next year, what's happening 3 years from now, and in both cases, what happened was outside of what I would have predicted, which means I am to some extent humbled. Like I think that there's more movement in compute at the moment than at previous times in my career, where I was very comfortable doing 3 or 5 years forecast and was occasionally, like I was right-ish most of the time. So was some definition of right.
It's hard to predict things. One of the co-authors of Attention is All You Need is actually a classmate of my university mate, right? And when they wrote that one, right, they essentially soon gave up research in AI because they also said that we're not quite there yet, the competition is not quite there yet, and they pivoted to other things. It was 2017, so 2017, so they actually pivoted to blockchain. And fast forward 5, 6, 8 years later, it changed a lot. And you could not call them incompetent on the question, like they were the best guys who knew the field at the time. So yeah. But actually, speaking about that, could you name some under-researched idea, in your opinion, where any kind of lab or company or startup could make a globally relevant dent in the next year or few?
So, I think one thing that's been on my mind for a while is if you think about human reasoning, I think at least I can only talk about my internal perception of what's happening inside my head. But there's an inductive and a deductive problem solving part. The deductive part is you need to calculate through a whole bunch of stuff. You need to do a whole bunch of equivalence transformations and so forth. It's reasonably mechanical. It's mechanical logic, so to speak. And there's the inductive part where you get a flash of insight, this is the right path to go down. And in the past, most of our computing algorithms, if you look at something like a chess engine and so forth, we were very good at the deductive part, automating the deductive parts in computers, tree search, whatever. And we did not have an inductive part. And now when we're asking an LLM to do computation, we're essentially asking the inductive part to do something that's really not good at. Right. So what I really think is very valuable to look into when it comes to code analysis, at least, is trying to build something where the AI takes the inductive part of the process of analyzing code, and you use theorem provers, something like Z3, whatever, to do the deductive reasoning and then establish feedback loops between the two. And I think there's a lot of mileage in that, in a variety of different fields, right? Because the Gen AI tools, like they have a tendency to generate the same bad idea over and over again, but they can also generate various different ideas and try them. And if you look at the role of AI in a Go engine, for example, in AlphaGo, if you've played Go, as a human, you can stare at a board and have a rough idea of what the position is. Like your human brain has a sort of value function where you can't quite articulate why this board looks advantageous to player A versus player B, but it's there. And for a long time, the progress in Go engines was stalled on not having a good valuation function to tell you whether you're making progress with your moves, right?
That's actually formalized.
Right. And so in the end, what DeepMind did is throw in a network on it to learn a valuation function from a lot of game rollouts. So the network took over the inductive part again, like the part that is difficult to articulate, that isn't deductive in nature. So I think in general there is a lot of room to combine Gen AI with deductive reasoning tools to perform the deductive part. An example is when you try to do formal verification of code, right? Somebody needs to write all these proofs.
Yeah.
And as the AI tools become a little bit better at writing things that you can throw into Lean, like the theorem prover or any other theorem provers, you will see progress where the AI guides something and then the theorem prover provides feedback until you eventually get things done. So that's one thing I find interesting. Another thing I find interesting, but that's something on my mind for a long time. I'm not sure whether it'll ever be a thing, but I've always found the use of AI for deception or for containment interesting. I still quite like the idea. I'm not sure whether it's ever going to be practical, but having a combination of detecting an attack and automatically migrating the attack system into an isolated VM with bullshit generated as input and output. So in essence, you detect somebody attacking a machine, you clone the VM for that machine, and move it somewhere safe where the attacker can't actually touch anything important.
Before they kind of...
And then you give the attacker access to that isolated VM that is in an environment where there's nothing important. And then you let the attacker do whatever they want on that machine. And that's not a good business idea because no business is going to pay for attacker capture and detainment, right? But if you had the ability to automatically migrate attackers into a virtual environment where they can fool around and you can watch them, I think that would be very useful in many scenarios because it's very hard for the attacker. Like, I mean, we talked about when we talked about the AI agents dueling. Like, one of my favorite analogy for conflict in cyberspace is phantom chess. So it's a chessboard where you don't see your opponent's pieces, and only after you've taken a move, you know what the effects were, right? And only locally, because you may make a move and you may take the other side's figure, and then you see the figure, but not previously. And to some extent, we're not using that asymmetry well enough yet. Like, an attacker that attacks a machine will have a very hard time figuring out that this machine isn't real once they're on the machine, if the machine has been cloned from a real machine, right? So you're tying up attacker resources on something that is of no value while the attacker does things that you get to observe.
That's assuming you can do it in time before they escape to like some different machine and move laterally.
Oh yeah. I mean, you but I mean that's why it's
non-trivial.
Not a problem really, because the attackers are not like constantly present on a system. Just there is like a monitoring piece of it. So if beacon, if an agent, like not AI agent but access agent, pings back that it's alive, no one will pay attention. So if you do not, please go on.
You can live migrate, like the cloud providers can live migrate VMs.
Yeah.
Right. So
the change will not be like visible, like obvious to an attacker, if you work on generating like the same signals they intend to observe once they're in, right? So if you somehow emulate everything that was visible from that machine and what was of value to the attackers, they most probably will not pay attention to any deviations because they will just not look that way. Unless you install VMware tools or anything on the guest machine.
Well, if you did like complete escape of like through the levels, then through the isolation levels. That's very interesting. So like that's a continuation of Canary's idea. Now when the canary is triggered, you put the attacker in the matrix essentially.
Yep. And Gen AIs are reasonably good at generating bullshit data to feed to the attacker then.
Yeah. It will take some time.
Bullshit data.
Eventually they will
real.
figure it out.
Yeah.
But at least for some time it will look real to them. So it sounds quite promising to me.
Awesome.
And again, economically, it's quite interesting. I do not share your pessimism regarding that. No one will ever pay for that. I think that could have some market in certain government institutions, because it looks fancy, and it's within some doctrinal conditions that are building up in the Western policy. So.
You just need to find the good. Sorry, you just need to find to sell that. You just need to find good sales words, right? Don't say it like put it in a VM. Say it, put it in a matrix. That sounds better.
Yep, exactly.
I think the other part is it's not a product that you will be able to sell to businesses. It is a product you will be able to sell to sovereigns.
Probably,
like militaries, defense organizations, and so forth. But I guess what I'm saying is Walmart is not going to be incentivized to do this to an attacker.
Yeah.
Maybe Amazon will. Who knows?
Yeah. Which
depends on the
scale.
Is,
at what point will Amazon and Google need their own militaries? But it's
the line between sovereigns and big international corporations.
They probably already need. They just shy to acknowledge it and act upon it.
So many signs that we are moving towards cyberpunk future. So never say never.
Yeah. It was a novel. It wasn't an instruction manual.
Absolutely. Well, we already passed our time, and we just want to be mindful of your time. So we always wrap up by the same question, and that would be, what would be your advice or message to our Ukrainian listeners?
Oh my, I don't know. I didn't read that in the previous doc, so I'm really quite stumped as what to say. Like I don't think I know at a deep level what life is like in Ukraine right now. So it's really difficult for me to give advice or message. I guess, yeah, and almost anything I would say would come off as a platitude. So I'll just shut up, and I'll say I'd rather listen to what the Ukrainians have to say.
Actually, I think many Ukrainians would want that, but not from people like you. More from people like, more state leaders for sure. But I think many will find that would find this behavior model valuable for many folks. So we definitely appreciate that as well. Well, do you want to say something? Yeah.
No, I'm happy.
Awesome. With that, I want to wrap up just to make sure we're all on time. Thomas, thank you so much for coming. It's been a very interesting and deep conversation. Hugely appreciate it. And looking forward to more interesting stuff from you.
Thank you so much for having me. It was a really interesting conversation. All right.
Thank you very much.
Likewise. Thank you.